Okay. First thing we're going to talk about is graphing piecewise functions. This is problems on the back of your paper. On the back of your paper, you guys had to graph piecewise functions. I'm giving you all a piece of graph paper. How can you guys feel right?
Oh, I have my whole note of graph.
Because I think this is the best, the easiest way for you to be able to learn how to graph piecewise is by using graph paper. You attempted it, but not exactly the way you did it. Good job. You did try. I appreciate that. Okay. Here's the problem. Okay? This is an example. I want you to graph f of x for x plus 6 when x is less than or equal to negative 4, and 2x minus 4 when x is greater than or equal greater than negative 4. All right? Now, with that said, y is equal to x plus 6 is the first function. True statement? What does y equals mx what does y equals x plus 6 look like?
Start at 6 and go up.
So you're talking about a line, right? So my slope is going to be 1 over 1, which is up 1 to the right 1. My y-intercept is going to be the point 0, 6. That's exactly what Stacy was just talking about. Starting at 6, go up 1 to the right 1, up 1 to the right 1. Why is this what it is? Because this number in front of the x is my slope, which is understood to be 1. Make it a fraction because slope is rise over run. Yes? The b value is my 6, which is my y-intercept, and we put that in an ordered pair format, which is the point 0, 6. Agree? We good? Okay. So now at this point, I'm simply going to graph this. And I really, really, really despise this type of graph. But I cannot figure out how to get my old graph paper up here. I'm working on it, okay? Okay. So now, if I start at the point 0, 6, I'm going to go up 1 unit and to the right 1 unit. Up 1 unit to the right 1 unit. Up 1 unit to the right 1 unit. Up 1 unit to the right 1 unit. Do we see that's the top part of the line? Yes? Now I want to go get the other quadrant too, so I'm going to go from 0, 6, I'm going to go down to the, and to the left, down 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 to the left. Do we see the line? Now if I draw this line, oh, that was a frightening line. Oh, it's still frightening, but we're going to pretend it's okay. There's my line. Now it says for when x is less than or equal to negative 4. Well, where is x equals negative 4? It's right here. There's the point. So what I'm going to do is I'm going to erase everything else above it. Because I cannot be on that part of the equation when x is greater than negative 4. Do we understand that? Yes or no? Because I cannot choose x values greater than negative 4 on that specific x plus 6 line. Yay or nay, people?
Yeah.
The arrow is pointing to the left, so it has to be less. Okay? Okay, we understand the red equation right now, and the graph of the red equation, and why I have started it at negative 4 and it's going down, right? Okay, the next one I'm going to do is the 2x minus 4. So what's my slope?
2.
My slope is 2 over 1, which means I'm going to go up 2 units and to the right 1. And what's my y-intercept?
Negative.
Give me a point, please.
0.
Thank you. So now I'm going to start at the point 0, negative 4, which is right here. No, it's not. Sorry. 0, negative 4. That puts me right there. At the point 0, negative 4, from there I'm going to go up 2 units to the right 1. Up 2 units to the right 1. Up 2 units to the right 1. up 2 units to the right 1, up 2 units to the right 1, up 2 to the right 1. Do we all see that? I'm going to go down 2 units to the left, 1, down to the left, down to the left. Okay? Do we all see the line? Okay? So now at this point, I'm going to connect those dots. Now, can anybody tell me where that's going to start at? This graph is going to start at -4. So here's -4. And it looks like I didn't go quite enough over. And it would be clear down here. You see that? It's off the graph there. Yes? Now you tell me. Do I need all of it or none of it? I'm going to use the 2x minus 4 graph when x is greater than -4. So what you're going to do, at -4, you're going to have an open dot. And it's going to go up. But it cannot go below -4. And it cannot be -4. So that's why you have the open dot at -4. Do we all understand that, yes or no? Okay? So I have the open dot at -4 for the second part of the graph. Kelly, are you good, hon? Yeah. Kendra, are you good?
Yeah, I just didn't know why there wasn't a dot like on the first one.
It's a closed dot on the first one. It is literally like it's closed. It's there. Okay? It's a big closed dot on the first graph. Do you see that?
Yeah.
On the second graph, it's a big open dot because it cannot be it. Any questions on what I just said? We good? All right, does everybody understand how to do 7 and 8 on the back of your graphs there? Should we do one? Okay, let's do number 7. So if we're doing number 7, I have 3 different graphs, right? Let's do the really easy one first. Which one's the really easy one?
-2.
X equals -2, or y equals -2 is the absolute easiest one up there, right? It's a flat horizontal line, right? At the value -2. Well, if it's going to be a horizontal line at the value -2, sure wish I could draw today. There's y equals -2. Agree? However, I can only be on there when it's in between what values? -3 and 1. Can it be -3? No. So at -3, I'm going to have an open dot. At -3. And at 1, I'm going to have an open dot there. And the rest of the line goes away. Do we see that graph there? Yes or no? An open dot at -3 and at 1. Do we see it? Okay. The next part is going to be the x plus 5. For x plus 5, what's my slope? 1/1, up 1 to the right 1, and what's my y-intercept? 0, 5. Do we agree? So where do I start at? I go up to 0, 5, which is right there. I'm going to go up 1 to the right 1, down 1 to the left 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 1. Do we see that? Now, where am I going to draw this line at? I'm going to choose all the values for when x is less than or equal to -3. So where is x equals -3? It's right here. And it can be it. And all the other dots go away above it. Because it's less than or equal to it. Do we see that? Does everybody see that? Yes or no?
Yeah.
Does someone say no? My last one is going to be y is equal to 5x minus 4. So what's my slope? 5/1, up 5 to the right 1. And what's my b value? My y-intercept? 0, -4. So I'm going to start at 0, -4. That puts me right here. And I'm going to go up 5 units into the right one. Up 5 units into the right one. Do we see that? Now, folks, it says when x is greater than 1. Greater than or equal to it. Can I be equal to the 1? So I'm going to go to the 1, and it can be it, so it's a closed dot. And I want the values greater than it, which is why I'm going to draw my line, and the 1, 0, -4 goes away. I don't need that point, do I? And there's my graph. Now notice, does this span all the way across from -infinity to infinity?
Yeah.
It does, because whenever it's below -3, it goes to the x plus 5. When it's between -3 and 1, it goes to the green one, which is going to be then y equals -2. And when it's greater than 1, it's going to go to the blue one, and it's going to go up. Do we understand that, yes or no? That is your piecewise function. Any questions? Excellent. Next. Number 9. Number 9 asks you to do even, odd, or neither. Now what I'm going to do is I'm going to show you something graphically. Okay? Graphically, we are going to graph this thing. So I'm going to have a new document here. View, scaling 200%, menu. I'm going to add a graph. Okay? So everybody should have a graph, yes? Now we're going to graph this number 9, and number 9 on the paper was x to the 6, so I'm going to type x, caret 6, right arrow, minus 2x squared, right arrow, plus 3, enter. There's my graph. There's my graph. Now, how does this help you? If you are an even function, which direction can I fold it?
I think I would have changed the language. How did I even get there? I don't know.
If we want to tell if this is an even or odd function, what do I need to look at? An even function says that I can fold it vertically over the y-axis, and the entire graph will lay on top of each other. Yes?
Yeah.
And it'll be pair for pair, point for point, exactly the same thing. Can I fold this over the y-axis and do that?
Yeah.
Yes. An odd function says I can fold it over the y and then over the x. Would this be an odd function? Can I fold that vertically and horizontally and lay directly on top of each other? No. So what are you concluding looking at this graphically? That is an even or odd function. It's an even function if you look at it graphically. Now, I want to prove this algebraically, that my findings, looking at this graph, graphically, it is an even function. How do I prove that? Well, I'm going to prove that even function, you have to memorize this. It says that f of x is equal to f at negative x. An even function says that f of x has to equal f at negative x. While an odd function says that f at negative x has to equal negative f of x. That's a lot of f of x junk going on there, isn't it? Okay, here's what you need to know. You need to have your original. Okay? Then you need to do f at negative x. F at negative x says I do what? Every place I see an x, what do I plug in? A negative x. So that's what I'm going to do. Negative x to the 6 minus 2 to the negative x squared plus 3. Now, when you take a negative number and you take it to an even power, what's the outcome? Positive. When you take a negative number and you raise it to an odd power, what's the outcome? Negative. Do we all remember this? Negative number to an odd power is negative outcome. A negative power to an even power, a negative number to an even power is going to be a positive outcome. So with that said, negative x to the 6 gives me what?
X to the 6.
X to the 6. Negative x to squared becomes what? Just x. So this is negative 2x squared plus 3. That's done. Do we see that? Okay. We're not going to do any comparing at this point.
Wait,
What else do I have to do?
did you just get rid of them?
What's a negative times a negative, Rachel?
Oh, okay, you did that. Okay.
In your brain, that's what I just talked about. If it's raised to an even power. You good? Okay. Now, the next thing you need to do is the negative times f of x. What do you do with the negative? What property is that called? The distributive property. So you're going to distribute that into your f of x function. So if I distribute that, that gives me negative x to the 6 plus 2x squared minus 3. Now, we have our two boxes, right? Now, what we have to do is prove that f of x, which is right up here, is equal to f at negative x, which is right down here in the first box. You see those? Are those functions equal? Are they exactly the same function? Since they are exactly the same function, then it is an even function. Notice f of negative x and these two black boxes do not equal each other. If the two black boxes would equal each other, then you could determine if that was an odd function. But they don't equal each other. Did we see that? Yes? Okay. Any questions on what I want you to do for 9 through 14? Any questions on that?
How would you do
11. Okay, there's my f of x, right? So now I have to do what? So I have negative x times negative x plus 5. Right? And negative times that is going to be exactly negative x times the square root of x plus 5. Okay, which boxes equal each other? Do any of the boxes equal each other? Since no boxes equal each other, it's neither. Do we see that? This is neither. In other words, I can't fold this over vertically or vertically and horizontally. And if you look at the graph on that, if we add a new page to this, that was what? X times the square root of x plus 5?
Yeah.
Can I fold that vertically over the y-axis and that be symmetrical? No. Can I fold it vertically and then horizontally? No. Can you see that that's neither graphically and algebraically? Yep. Do we see that f of x is not equal to f at negative x for the even, and f at negative x and the negative f of x, the black and the green, do not equal? Okay? Any questions on even and odd? Okay, the last part. Number 16. Okay? Number 16 says, I give you this 0.49. Okay? What I'm asking you to do, bless you. I give you the 0.49, which is right there. And if I want you to think of this as having a slot of pink paint right there, okay? If you fold it vertically, where's that slot of paint going to be at? If I fold it vertically, it's going to end up here at -4, 9. So my even means I fold over the y-axis to get the point -4, 9. Do we see that? Now what does odd do? What does odd do? Odd, you're going to fold over the y-axis and then the x-axis. So I go to my even point, and then I'm going to fold that over the vertical, over the x-axis. So what's that going to give me? I fold it down. So where's it going to put me? -4, -9 is going to be my odd point. Do we see my actual numbers of 4 and 9 stay exactly the same? What changes is its sign and what quadrant it lies in? Do we understand even and odd based upon that? And that's exactly what it means, you know, to be symmetrical, right? Any questions over that? Quinn? Yep. I would always do the even point first, because then from the even point you can get the odd by just folding it over horizontally. Okay? What, Mark? Yes. Are we all good on the back side of the worksheet from Friday? Any questions on the back side? For 16, even you're going to put -4, 9. For odd, you're going to put -4, -9. Caitlin, are you good? You don't understand? I want you to consider that to be a paint blotch. Okay? When I fold it directly down vertically over the y-axis and I fold it over, where's that paint blotch going to end up at? It's going to leave a mark at -4, 9, right? That's what it means to be even. You fold it over the y-axis. To be odd, you fold it over the y-axis, then you fold it over the x-axis. So now the paint blotch, I fold it over, ended here, and now it's going to come down here. Does that make sense? Yeah. Better? Okay. Now, the front part of the worksheet. Are we ready? The front side. I keep losing the worksheet. All right, now let's talk about number 6. Number 6 says to tell me increasing, decreasing, constant, and exponent, right? So what we're going to do is we're going to pull this thing up. Okay, I'm going to add a new page, Control Doc for new page, and I want it to be a graphs page. And that function was 2x cubed, 2x caret 3 right arrow plus 3x squared minus 12. And hit enter. Now this is what you get. That's not very pretty, is it? I can't see too much on that. So what I'm going to do is I'm going to hit menu, zoom, and we're going to do zoom fit. Menu, window, and we're going to do zoom fit. That's what I'm talking about. Do you see that? I can see the whole thing. But look at my scale. Look at my scale. What's wrong with my scale? It's not proportional at all, is it? Not at all. So what we're going to do is we're going to take this y-axis and we're going to spread that bad boy out. I need to see what's going on in there. Do we see how I can change the look of that and it looks different? Okay? So what we're going to do is we're going to go to Menu, Window, and then Window Settings. Menu, Window, and then Window Settings. And I'm going to say -10, tab, 10 is my max, tab, scale of 1, tab. Let's do -15 as my min, tab, to 15, and let's go by scales of 2. So my x-mins are from -10 to 10, scale of 1. My y-mins are from -15 to 15, and scale of 2. Because I want to really see what's going on around that x-axis. Do you see that now I can see a little hump in a valley? Before I couldn't see the mountain in the valley, could I? And I need that mountain and valley because I need to know, I need to put that on my paper, don't I? So grab your paper right in the middle. Turn that to a hand and grab it up. You see that? Turn it to a hand and grab it up. You can move your paper all around. Okay? Okay. Now, is everybody paying attention? Now I want you to hit menu, and we're going to do analyze graph. What do you think I want? Sorry? Min or max. So where's my minimum at? Is it the mountain or the valley? It's the valley. So I'm going to go to the left of the valley, and I'm going to go to the right of the valley. And I'm going to click, and there it is. My minimum point is at 0, -12. Now I'm going to go to my maximum. So I'm going to go ahead, menu, analyze, max. I go to the left of the hump and the right of the hump. And now I have -1, -11. Isn't that great? It does your max and your min for you. Okay? Now, why would this be helpful to me? Why do I need to know those max and mins? Because how do you read increasing, decreasing, constant values from? Which direction?
Left to right.
Left to right. So this thing is increasing from which direction? From the left. Please don't try that. I'm increasing from -infinity to where? To -1. And then I am decreasing from what? At -1 to where? To the 0. And then what happens at 0?
Increasing.
Then I'm starting to increase from 0 to infinity. Now I'm missing one other piece of information, aren't I? What's my maximum point? -1 to 11. And what's my minimum point? 0, -12. Do I have any constants? No. No. So on the constant line, what do you write? None. Okay? On the constant line, you write none. Do you see how we had to find the max and min there first to be able to do anything else? Okay? Do we understand the front increase, decreasing, constant, max, and min better? Andrew, are you better? Okay. All right, now we're out of time for today. Now here's what's going to happen tonight. What I want you guys to do for homework, to finish this worksheet, and then I'm going to pass out the review, because I think some of you are already done with this worksheet and you understand it. It's going to take you like 5 minutes to fix it. So I want you guys to have an idea of what I'm going to be talking about tomorrow in class. Oh. There's your paper.
That time went fast.
Okay. Now, I want you guys to put your calculators away correctly and flush. There's been several of them that I've had to twist to get out.
When's the test?
The test will be Wednesday. Tomorrow I will review with you. The test will be Wednesday.
Great, I need my...
Hey, you want this?
Okay.